In this video, I will explain how to maximize utility given two goods that are considered perfect complements. So let's check out an example. This says, suppose a consumer has the utility function u equals the minimum of 2x and 3y, where x is one good and y is another good. Find the maximum utility given the price of good x is $4, the price of good y is $6, and the consumer's income, M, is $120. So when we have a utility function in this format, the minimum of two quantities, this tells us that these two goods, x and y, they are complementary goods. And what that means is that these two goods complement each other in such a way that you maximize your utility when you consume these two goods in a specific ratio. And in this case, we maximize our utility when these two values are equal to each other. So when 2x is equal to 3y. So let's write that down. So the maximum utility occurs when 2x is equal to 3y. Now remember our objective. We want to maximize this function, but we have some constraints. We only have $120 to spend. So what we need to do is write our budget constraint equation, which takes on this format. M, our income, is equal to the price of good x times the quantity of x plus the price of good y times the quantity of y. So let's go ahead and fill in the values that we know. M is 120, so let's write 120 is equal to the price of good x is $4. So we'll say 4 times x, remember x is the quantity, this is what we're trying to figure out, plus the price of good y is 6, so we'll say 6 times the quantity of y. So we're also trying to figure out this y. Now notice what we have here. We have this budget constraint equation and we have this equation right here. We know that our utility is maximized when 2x is equal to 3y. So what we can do is we can solve for x right here and then plug it into this equation. So when we have 2x is equal to 3y, to solve for x, we can just divide both sides by 2. So the 2's cancel out here and we're left with x is equal to 3/2 y. So now what we can do is we can plug in this value for x over here. So let's go ahead and do that. So we'll say 120 is equal to 4 times, we're plugging in a 3/2 y. Plus 6y. So we get 120 is equal to 4 times 3, that's 12. So we really have 12 divided by 2, which is 6. So this is 6y plus 6y. So then we get 120 is equal to 6y plus 6y, that's 12y. Lastly, to solve for y, we can divide both sides by 12. And we find that y is equal to 120 divided by 12 is 10. So we maximize our utility when we consume 10 units of good y. And if we consume 10 units of good y, how many units of good x would that be? Well, all we have to do is plug in a 10 right here for y. So we would get x is equal to 3/2 times 10. So this would be 3 times 10, that's 30, divided by 2 is 15. So x is equal to 15. So we maximize our utility when we consume 15 units of good x and 10 units of good y. So let's go ahead and write that here just to make it obvious that this is our answer. Now what we'll find is that when we consume 15 units of good x and 10 units of good y, we use up all $120 of our income and we maximize our utility function. Now to figure out what the value of the utility function is, all we have to do is plug in a 15 for x and a 10 for y. So when we do that, we see that u is equal to the minimum of 2 times, for x we're plugging in a 15, and for y we're plugging in a 10. So that's the minimum of 2 times 15 is 30, and 3 times 10 is also 30. So we get the minimum of 30 and 30, which is just 30. So the value for our utility would be 30. So that is how you can maximize utility given two goods that are considered perfect complements.